Okay, hello boys and girls. Welcome to Work on It Wednesdays. Today we are going to look at question 2 of this grade 11 paper, just 2.1 and 2.2's first one, which is a simultaneous equation solved for x and y simultaneously, where my first equation looks like this and my second equation looks like this. If this is your first time joining, welcome to Work on It Wednesdays. This is the third episode. You can catch up on episode 1 and 2. There's a playlist, Work on It Wednesdays, if you want to, where we basically work on grade 11 work and question papers, which is handy for the grade 11s and 12s also. And you can come join us every Wednesday for Work on It Wednesdays. Right, solve for x and y simultaneously. So usually when I have two equations that I want to solve simultaneously, I use the method of substitution. So I'm going to use that method. If you use another method, it's fine, but that's the method I'm using, is substitution. The first thing is I want to get x or y alone. Now I already have y alone, so that's perfect. I can actually just go on ahead to the second step and substitute this into the other equation. So y and x minus 1 is the same thing. So this y I can make x minus 1. And then the rest of the equation stays like that. Okay, and then I'm going to solve for x on this side. Okay, and then when I get an answer, I'm going to substitute that back into this equation. Right, so I'm going to solve first on this side. So this is quadratic. Since I've got x squared positive on this side, I prefer to just get everything to this side. So 2x minus x is just x. And then minus 7 plus 1 is minus 6. And I'm going to factorize this. If you are still not comfortable with factorizing, there's basic concepts and principles there's a playlist, basic concepts and something on my channel, MrsMath, that you can just go to that playlist, and there's a video on all of the types of factorizing, and also videos actually on all of the types of solving for x, like linear equations, quadratic, exponential, all of the types. So if you are not fine with those things, I urge you, please go and watch those basic concepts, not just go and watch them once and forget about them. Go and seriously sit and watch them and figure them out, and even watch them over and over and over again until you are very comfortable with factorizing and with solving for x, especially if you are moving towards matric. It's really important that you must be able to factorize and solve for x, and do that comfortably. Not even I'm able to do that, but yes, I'm able to do that. Like, you must be very comfortable with it, and you must know how to do it without any doubt. Right. So here I now get that x is minus 3, or even x is 2. Now I said I'm going to solve and find an answer. Now I'm so lucky I don't have just one answer, I have 2. Okay. Ain't I lucky? I've got more than what I need. Right. I need an answer and I've got 2. Right, okay, so I'm just going to use both of them then on that side. So I'm not going to work there. I'm going to just go on here, like on the same level where I am, because if the person marking my work doesn't understand that I first worked on this side and then moved to this side, when I put x minus 3 there, he's not going to know where did I get that. So I'm just going to work like this. Okay, so I've got 2 answers. X is minus 3 or x is 2. And now if x is minus 3, this becomes y equals minus 3 minus 1. And if x is 2, it is y equals 2 minus 1, which means y is minus 4 or y is 1. And then I do prefer, if you just write for clarity's sake, I've got 2 sets of answers here now. I've got an x minus 3, and specifically for that x minus 3, my y is minus 4. So these two go together, I put them together. And then I've got a x that is 2, and those two go together like that. Right, I've got an x that is 2, and that y that goes with it is 1, and that's my answer. I've got two sets of solutions, x and y. Okay, so that's simultaneous equations 2.1, perfectly good. And then the next question is exponential simplification without a calculator. I love exponential questions. I love them. I love them. Love them. I was so looking forward to just doing this problem this week. And the reason I love them is I click them. Like when at first I started with this, I hated it because I didn't do them fast. I was struggling with them. I didn't understand the relationship between the problems and those laws that they make us study over and over and over again each year. And I was really frustrated with this. But once I just clicked, oh, okay, now I have it. Then I never struggled with any of this again. Doesn't matter how difficult you make it. So now I just love this chapter. And I urge you also, if you struggle with this, just sit with the laws next to you when you do problems and just do it with the laws. And even if you work slowly at the beginning, just train your brain so that I now wipe this off. Just train your brain so that you can really get to a point where you can do it comfortably and you know fast what to do and how to do it. And then this will be fun for you too. Right. Okay, now most of the time, like 95% of the time, when working with exponential expressions, my bases are not the same. The first thing I'm going to do is prime factor form all of these. If you don't know what prime factor form is, please, that basic concepts playlist that I was talking about earlier, it also contains a video about prime factor form. Go and watch that video. Right, because you must know what prime factor form is. Now, you can, if you have this Casio brand calculator, you can do the shift fact to get the prime factor form. But since this question stated simplify without using a calculator, I'm going to really commit to doing this without the calculator today. Right, so I've got 12 divided by 2 divided by 2, it's 3 divided by 3, it's 1. 27, I'm going to do this all by hand now. And 18. And if you don't know what is MrsMath doing here at the moment, I am so confused. Go and watch that prime factor form video. That will clear it up for you. And you will know exactly, oh, I know, this comes from primary school. You've done this in primary school. Right, so now I'm going to substitute these things like the prime factor forms. I'm still going to have 12 to the power of n plus 1, 27 to the power of n minus 2 over 18 to the power of 2n minus 1. So I'm still going to have those powers exactly there. Just 12 is now going to become 2 squared times 3. 27 is 3 cubed. And 18 is 2 times 3 squared. Right. And usually I would rather leave this here so that people can see, yes, I did this all by myself without a calculator. But I'm going to take it off now because I want to write down the exponential laws as I use them next to the question for you. So if I look now at this, I see exponential laws here. The first one I notice is there's that one that says AB to the power of n is A to the power of n, B to the power of n. I've got different bases with an exponent, then this exponent applies to that one and to that one. Right, that's the first one I see. And that's also the same one that I'm going to use actually with this one. And then I also see another one that says if I have an exponent of a base with an exponent m, and I have that to the power of something, to the power of yet something else. So there's two powers involved on top of one another, which will also be the case now here, and it will also be the case there. There's a 2 to the power of a power of 2 with another power of 2n minus 1. There's a power of 2 with another power n plus 1. So if I have two powers on top of one another, I can multiply those two powers on top of one another with each other. Right, and when you multiply this 2 with the n plus 1, it's like that, 2 times n plus 1. So you must multiply the 2 with the n and with the 1. Right, so be careful that you don't just multiply the 2 with the n. You must also multiply it with the 1 when we get there. Right, so I'm going to do these two things now. I've got 2 to the power of 2n plus 2, 3 to the power of n plus 1, 3 to the power of, are you still awake? I'm going to multiply this with both of them. Yes, brilliant. Okay, so that's going to be 3n minus 6. And then here, I'm going to take 2 to the power of that, 2n minus 1, because there's brackets and a power, this power applies to both. And 3 to the power of 4n. And what's this going to be? Be careful, you must multiply the 2 with both of them, so that's minus 2. Okay, great. Fantastic. Okay, and from here on, I'm just going to work with the 2's together, the base 2's and the base 3's. I'm going to work with them together, like separately in their own way. Okay, so here I see with the 2's, if I look at them, I see the law that says a to the power of m over a to the power of n. My bases are the same. Then what I do is I just subtract my exponents. And be careful, you subtract the exponents, but don't change your base. Don't divide the two bases with one another. It stays that same base that was on top and at the bottom. It still stays that. I just subtract my exponents, right? So I'm going to have 2, then that exponent, subtract this exponent. Okay, and for the 3's, I also see a multiplication. There's one similar to this for multiplication. That says if I multiply bases or the same, base stays the same. Don't multiply the base. Make this a squared m plus n. It's just still a, and I can just add my exponents. So there I'm going to add those two exponents with the 3. I've got n plus 1 plus, if you want to put brackets here, it's not important because there's a plus, but whenever there's a minus, just put brackets around the whole thing. And then in the same step, I'm immediately also going to take this, because that's now divided by 3 to the power of this. I'm just going to subtract that also here. Okay, if you need to write it in a separate step, that's fine. But I'm just going to subtract it here. Now I don't need this anymore. So I'm just going to take it off so that it doesn't look so confusing here on my board and so clashed in here. Okay, and now I can just add the like terms. Now you can multiply the plus in and the minus in, multiply the minus in, and add the like terms. I'm not going to multiply them in, I'm going to just add them like they are standing here. So 2n minus 2n, that falls away, and 2 plus 1. It's minus 1 times minus 1 is plus. Okay, 2 plus 1 is 3. I multiply them in and add them together. Okay. And then for 3, I've got n plus 3, and it's 4n minus 4n. So the n's fall away. Okay, my numbers is 1 minus 6, so it's minus 5. I'm just going to keep that. And minus minus becomes plus 2. So minus 5 plus 2, it's minus 3. And then negative exponents, a to the power of negative n is equal to 1 over a to the power of n. Negative exponents just go under the line, become positive. So this is going to go under the line and become positive, which is 2 to the power of 3 is 8, 3 to the power of 3 is 27, without a calculator. That's my answer. And that's it for today's Work on It Wednesdays. As I said, if you have any interesting questions or even ridiculously difficult questions that you come across that you just want me to have a look at or make a video on solving them, please just let me get them. Like, put them in the comments below under this video. You can do that. Or Mrs. Math also has a Facebook page. You can just search on Facebook Mrs. Math and join the group there on Mrs. Math's Facebook page, and you can comment there on that group. If you have a question that you don't know how to type in the comments, you can just take a pic and share it on Facebook with me or whatever. If you want me to work out something for Work on It Wednesdays, or you even just have something that you think I will find this interesting and you want to share this with me, you are more than welcome to do that. Have a lovely week. I see you next week for Work on It Wednesdays. I see you next week. Enjoy your week. Bye.